Hi, I'm Beth Wilson. I'm one of the hosts of STEM in 30, which is a science program for middle school students that is produced here at the National Air and Space Museum. Welcome to our weekly live chats. Today, I am really excited. We are talking all about spacesuits. And to help us navigate the world of spacesuits, we have our spacesuit curator, Dr. Cathleen Lewis. We have our spacesuit conservator, Lisa Young, and we have NASA astronaut and veteran spacewalker, Colonel Anne McClain. Thank you all for joining us today. As I said, we're talking all about spacesuits. If you're watching online, please put your questions in the comments section, and we will get to as many of them as we can. To get started, I want to talk to Kathy. Kathy, can you tell us a little bit about collecting Apollo spacesuits? And importantly, what does Neil Armstrong's spacesuit tell us historically?
Well, Neil Armstrong's suit is really the crown jewel of our collection. We have a spacesuit collection that's the largest in the world. And believe me, I've seen others, so I can say that with great confidence. But we have everything from prototype suits, contract suits, lots of suits that didn't ever fly. But in Neil Armstrong's suit, we have that one spacesuit that allowed a human being to walk on another world. And it captured that moment when much of the world was watching simultaneously, watching him step down on the surface. And what people saw was not Neil Armstrong, the man, but that spacesuit taking that step down. And that in the days of stark, high contrast, black and white video footage, that's really the icon that it imprinted itself on people's minds in history.
And these suits were built specifically for the Apollo astronauts. So when you look at the tag in Neil Armstrong's suit, what does it say?
Size Armstrong. This suit, they took numerous measurements of each of the astronauts, and they fit checked and rechecked many times. So no one else could fit that suit but Armstrong.
And today there are a bunch of different astronauts doing a whole lot more spacewalking. So they don't build suits that are sized specifically for you. And it is understood that some of that sizing may have influenced a decision you had to make for a spacewalk you took.
Yeah, so the current spacesuits that we use on the International Space Station are built to be modular. So they get resized for whatever astronaut is going to be flying. And it's also, they were built for a variety of missions. The suits that we have on Space Station right now were built when I was in preschool. And so they have been around for a while, and they have contained astronauts of all sizes and shapes and to do a variety of missions. They really are amazing development. You know, they're almost more like a small spacecraft than they are a spacesuit. When you picture a spacesuit, don't picture us putting on, you know, our shirt and our pants. It's more like we are getting into a small spacecraft with its own power and electric system and pressurization system, and there's soft components and there's hard components, and they're amazingly resilient to temperatures and pressures and atmospheres. And so, but right now, the most of the suit is very modular. We can change the length, the leg length, the arm length, the torso size. The only thing that oftentimes is custom made to astronauts are the gloves. But even the gloves, they take measurements all the way down to how large where do our fingers bend? Because if you think about it, you and I may have the same size hands, but if our joints are not in the same place, then we can't wear the same size gloves, because what's really important is that the suit needs to bend where your body bends. And so you referenced a change of crew that we did up the space station. And you know, and I'd love to clear the air on that, because one of the things I want to emphasize is that it wasn't because we didn't have the suits or that suits didn't work. It's that the suit did work. After my first EVA, I went on a suit. The suit was perfect. I came back in. I had no problems with it. I was meant to wear a different size on the next one. But also that was only one small part of the decision. And so all the time when we were running these missions up in space, you know, I think people have gotten used to seeing astronauts outside, and it started to look routine. While NASA is amazing at making the extraordinary look routine, there is nothing routine about any day in space. It is always a conglomeration of a lot of engineers and risk mitigators, thousands of people on the ground from across the world to do things right. So on that particular day, just like everybody working at our agency, we looked at all of the risks, and we always want to put crews out that are the best for that mission. And so I recommended, based on many factors, the suit being only a small factor, that we change the crews up. Now those crew changes happen all the time. Unfortunately, that one got highlighted because it was going to be a historic spacewalk. And a lot of people ask if I was disappointed to not have done the spacewalk. And what I will say is that at NASA, we can't set out to make history, or we will accept risk that we shouldn't. We make history by doing the right thing every day and the next best step for exploration. And so it wasn't the right thing on that day, but I'm so happy that two of my best friends later that year, Christina and Jessica, got that opportunity to do that.
Well, I think that also brings the point that, wearing spacesuits and doing spacewalks looks routine, but it's not. I mean, it's a very dangerous thing to do, even though you might just think that it's work.
Yeah, it is. It is hard work. It's about 7 hours on the space station. We're usually between 6 and 7 hours is normal. We've had spacewalks that are longer and shorter. A lot of the times, those missions, we've never done those exact procedures on the ground. Back when we were flying shuttle, the spacewalks were very scripted, and that exact crew would practice that exact spacewalk many times.
Sure.
Well, now we go live on the space station for 6.5 months, and we don't always know what procedures are going to fall on our mission. So they are long and difficult tasks. They require probably more mental energy than physical energy, yet it's the metabolic equivalent of about a marathon and a half. I was a rugby player. I always say coming back in after a spacewalk, it felt a lot like after a rugby match. You are just mentally and physically exhausted, but you feel very accomplished. But you're absolutely right. Working out in the vacuum of space, humans were not built to be there. It doesn't have the right atmosphere. It doesn't have the right pressures. It has crazy amounts of temperatures. If the sun is hitting me in the front on a suit, that can be a 200 to 300 degree difference between the shadow and my back. And inside my suit, I can make a nice little adjustment because I want it to be 70 degrees instead of 68 degrees. So these machines, these spacesuits are really incredible.
Lisa, you work on conserving these spacesuits, and we just heard how Anne talked about she really works in that suit, which means there's a lot of sweat and breath and just gross people stuff. What kind of challenges does that create for you when you're conserving a suit, from the 1960s and earlier?
Yeah, so conservation of all the suits are complicated because, as Anne described, we train in textile conservation or objects conservation in museums to preserve single materials that we know a lot about. NASA, as she pointed out, has a history of using innovative materials made to do the job, get the job done correctly, often documented, sometimes not on the earlier suits. The challenges of all those materials together is a very big preservation challenge because we cannot take the suits apart. So whatever happens in them, however they're used, is how we get them. We like to keep them together because every single mark on the anodized aluminum or crinkle in the rubber or the outside layer staining, it all tells stories about the actual history and mission of that suit. But even more so, NASA cleans and decontaminates most of the items before we get them. We're not going to get a suit that was recently used with somebody's sweat in them or not. Although we have linked sort of chloride corrosion on the wrist disconnects, if you've heard me talk about them before, to some of that contamination from earlier suits in the spacecraft like Gemini and Mercury missions where they were in the suits much longer, and that really did impact the materials. But even cleaning them out presents another challenge because you've exposed modern materials to a chemical. And so we have to watch those materials really closely, learn how they degrade and what do we need to do to preserve them, and how we can keep these miniature spacecraft, as she says, together and preserved for the future so people can see them on display in our museum.
Well, we've got questions rolling in, so let's just get started here. Kathy, I think this is probably a good one for you to follow up on. Is the moon dust from these suits still damaging the fabric?
Well, that's really a Lisa question.
I'm sorry, it's a Lisa question. Lisa, Kathy.
Standing in for each other.
It is very damaging to the fabric on a microscopic level. You can see it embedded in the outer layers of the beta cloth, especially on the Apollo suits, which was a fiberglass material. So it was meant to keep meteorites and small particles from penetrating through the suits to the astronaut. And because there's no atmosphere on the lunar surface, the angular lunar dust particles have embedded themselves right into that fabric and has left a mark. But even though it looks like it's on the surface, you can't really dust it off. It's pretty secured to the fabric, and our only job is to make sure that it remains there and doesn't cause additional damage in the future.
We have
historic value, so we want to retain it just for the historic value to document what happened when they were exploring the moon.
Yeah, actually, if I could piggyback off what Kathy just said. We learn from our history, and we want to put boots back on the moon by 2024, and the only way we're going to do that is to learn those lessons of history. So the suits that you all have preserved and that information that you've kept and how that lunar dust affects the suit, how it sticks to the suit, where it embeds, the damage it does, that is very much informing the decisions that we're making on future designs of suits.
Correct. Yes, that's great.
Greg from Winter Garden, Florida, would like to know where were the Apollo suits made, and what did we learn from those suits to make better suits?
Well, if I can jump in, the one thing we did learn is that we're not going to use zippers to hold in the pressure on suits. That is first and foremost. The zippers worked through the Apollo program and a couple of repressurizations, but they swapped out the zippers very late before flight, and they're just not that reliable. They had a wonderful, elegant system that worked at the time. There were two heavy brass zippers with a rubber gasket in between, and when the suits were pressurized, that would form the seal. But you don't want to bet repeated pressurizations on that. All of the seals now are hard metal with a rubber O-ring or gasket in between and held into place, and those are far more reliable. Not as flexible, a whole lot heavier, a lot more mass, but they're more reliable.
And is it true that the suits were made by different contractors? Different components were made by different contractors. Is that correct?
Yeah, so the two major contractors were ILC Dover, ILC Industries at the time. They made the soft goods and components, and then Hamilton Standard made the life support backpack that provided communications, oxygen, cooling water, that actually the operational system, they integrated it. But all of the components were made by different companies. We had the Beta Shoe Company in Switzerland that made the boots. The zippers were manufactured BF Goodrich. All sorts of components come in from all over the world. Airlock Company made all of the aluminum components.
We've got a lot of people watching from DC, Illinois, Texas, Maryland, England, Minnesota, the Ukraine, Utah, Indiana, Florida, and the Netherlands. Thank you so much for watching. Keep those questions coming in. And somebody would like to know, how hard is it to take an Earth selfie when you're in your suit?
a space selfie, I assume they mean. So it's fun. Somebody read my Twitter. It's interesting because the cameras, so the gloves on the suit, they have to hold the pressure. And like I said, they need to bend where your fingers bend. So they're actually quite robust. And so right now our gloves, if you relax your hand, they kind of go to about a 45-degree angle. And that's a change off a former suit. Sometimes some of the old gloves would actually kind of keep your hand in this position. And when you're under about 4 psi of pressure, you have to use muscles to grasp, and you have to use muscles to open your hands. And so a lot of what we do during our 7-hour spacewalks is try to conserve that energy. So you'll see us, instead of moving on station by gripping, the handrails like this, we try to just kind of lightly move ourselves along to try to conserve that hand strength. Well, taking pictures is strangely one of the things that can be really fatiguing on your fingers, because we take out our normal cameras. They just have a thermal blanket around them, and then we take pictures, but we also can't hold them up to our eyes. So whenever we go to take a picture, we actually take about 30 pictures and just hope that some of them, the ground sifts them through. And so when you're taking a space selfie, there's a couple things to think about. One, you've got the camera turned around. It's gigantic. You can't really feel the button, so you're just pressing and you're hoping. And you're not holding on to anything at that time. And so you put your tethers down and you start floating away. And so the Earth, you may think you have a great picture in the back, but then all of a sudden you start floating away because you have nothing like hard to the structure. So a lot of I hate to say this, but a lot of the pictures that you see of astronauts out on spacewalks were probably one in a series of 30, and probably the only good one.
Lisa, Jack would like to know, what was the most challenging piece to restore on Neil Armstrong's suit?
Oh, that's a good question. I think the gloves, as we've said, is one of the more challenging aspects. We have never displayed the gloves actually attached to the suit because it causes problems for the display, and we made the decision with the Armstrong display that we were going to represent the piece as it was on the lunar surface. So designing the mannequin to hold the glove in its original position but not have it attached to the suit. The gloves are super fragile, as Anne says. They're used the most. They were used quite a lot in the Apollo missions, and some of the materials are degraded more than you would see on the suit, just because of use and also the size of that object. So, and I think they tell the more personable stories, as she's pointed out, about activities that they did, even getting in and out of your spacesuit with the gloves, taking them off to do activities within the command module and LEM and things. So they're a very special piece of the suit, and they can't be replaced with any other part.
And Brooklyn would like to know, what do you wear underneath your spacesuit? It's not normal everyday underwear, I understand.
No, that's true. It is probably the most expensive piece of underwear that I've ever worn. So we have 2 layers that go underneath our suit. So right up against our body, we wear basically what looks like long johns, just a real thin piece of material against our skin, and that just kind of gives us a little bit of buffer between our next layer, which is called the LCVG, the liquid cooling and ventilation garment. And so if you look at it, it looks like kind of a one-piece, zip up, like toddler pajamas is kind of the form that it is. And it zips up in the front, and then you'll see big ventilation tubes. If you see an astronaut, you can look these up online. If you see the astronauts have, you see big ventilation tubes coming up our backs, and they go all the way down to our hands and also down our legs. And what that tube does is it takes the air when we're in our suit, we connect it to the suit, to the PLIS, the big area, the backpack, if you will. And that provides us air circulation through the suit, and all those tubes direct the air circulation into our hands and feet for the airflow. And then also in that garment is very small tubes that run all the way around our body that is for liquid cooling. Given the specific heat of liquid, it is a lot more efficient to cool your body, or to cool anything with liquid, than it is with ventilation. And so the way that we actually control our core temperature during a spacewalk is the temperature of the water that is right up against our skin. And actually we do that by just controlling the speed through which we put the water into our suit. So if the water is really fast, then it doesn't have a lot of time to heat up because of our body heat, and so therefore it cools us more. And if we turn that flow down more, then it goes slower around our body, therefore our body heats that water up a little quicker. And so we wear those 2 things. We also wear instrumentation that gives ground data on our heartbeat. So we have some nodes kind of connected to our chest area. And then we wear undergloves underneath the gloves that we work in. And then for different crew members, the suits fit differently. So a lot of crew members will wear something like moleskin to prevent blisters, just like you would with shoes.
That's interesting. Kathy, somebody would like to know, how many suits do we have in our collection, and why don't the astronauts get to keep them?
Second question first. The astronauts don't get to keep them because they are federal employees, and like all of us who are federal employees, you don't get to keep your equipment when you leave the job. You don't take it home. It's federally issued equipment. But we have a collection of, it's hard to say, it's plus or minus 278 suits. That doesn't mean that we could outfit an army of 278 astronauts. Some of these are components. As I said, some of these are prototype suits. They're not complete. Some are asymmetrical, some of which we only have parts, maybe shoulders or arm joints, or we have suits without the shoulders and arm joints. So, and these go back to the pre-human spaceflight age suits that NASA used to develop ideas about what kind of spacesuits they'd like to use, including suits that had been accepted and rejected by the Air Force and the Navy during the 1950s. So it's a wide range of wonderful suits.
We've got, watching from Anne's hometown of Spokane, Washington, we have the primary school, Cadello Catholic School. We also have people watching in Arkansas, Kansas, Mexico, Ohio, Louisiana. So keep those questions coming in. Let's see. Is there a difference, Anne, between the suit that you wear when you're spacewalking and the one that you wear when you're training?
There is, yes. So the major components are obviously going to be the same in the way it feels. However, when we're training, we actually use old suits that are no longer in what we call Class 1 service, so suits that are actually certified to go up into space, and we use them in the swimming pool. And so if you can just think of, what swimming pool does to your bathing suits after a while, it's very harsh chemical having chlorine on those suits. And so those are our Class 3 suits, and so they're good for training in the pool, but we would not fly them because the materials wouldn't be sufficient. We also, when we train in the pool, the big backpack is the PLIS, the Portable Life Support System. Now, in space, that is all self-contained, and it has the real hardware that has our oxygen stores. It pumps the liquid and the air through our suits, and it scrubs the CO2 out of the air. Now, when we're in the pool, we are actually connected by a big umbilical. So all of that is just kind of a volumetric mock-up. Because those suits, like I said, it's like a small spacecraft that you get in. And so one of the important things to learn in space is, how big am I, and when am I going to bump things? Because when we go out into space, we obviously don't want to bump our backpacks, our suits. There are handles and switches that we don't want to damage. And we also don't, everything on the outside of the space station is quite fragile, and you don't want to inadvertently damage something. So the suits are different. Volumetrically, they're the same, and they bend in the same way. That's how we learn where we need moleskin if we need it. That's where we learn what sizing we need. And a lot of our initial spacesuit training is really trying to get that fit just right.
So we have a couple of, so I do want to mention that we are releasing Smithsonian Science Starters, and we were very fortunate to work with Anne and her colleague Nick on one of the first ones that we are releasing. So keep an eye out for those. They are coming out soon. We have a question about the layers from Frankie Cullen and Essen. Kathy, and I'm going to start with you, Kathy. How many layers do these spacesuits have, and why do they look so thick?
Well, the number of layers depends on which suit you're talking about and where you count. The Apollo spacesuits are commonly cited as having 21 layers. That's depending on where there are more layers on certain places of abrasion that the suits would have. And these are layers meant to insulate against solar radiation, help promote, insulation against generating or absorbing heat from the sun or out there, or temperature declines. They're supposed to operate at plus and minus 250 degrees Fahrenheit. But they're most importantly, the outer layers of the suit that sort of gives a bulk are actually very lightweight. These are lightweight fabrics, textiles that are interlayered in order to stop that particle traveling at 17,500 miles per hour. And the concept is that if a particle does, and these are tiny particles, smaller than 1/10 of a millimeter, if it penetrates the outer layer, it'll break apart, lose momentum, and that process continues as it proceeds through the layers, and at which point it comes to rest. And it has worked. It's taken out. They have a special test site where they test the layer stack just to make sure that it does work in principle. Now with the EMU that Anne wore, that has 11 layers. It's not that it's any less protective, but the technology, the materials technology has advanced, and Lisa can talk about that a little more. But what they've done is combine layers of textiles into a single layer, but they still have to take as much care. They have to test every single new lot that they get to make sure that this holds up the way that they expect it to do and the way the previous ones have done.
And Anne, when you're I'm sorry, and Lisa, I'm confusing everybody today. Lisa, when you're preserving and conserving these suits, are there challenges in dealing with so many different layers and fabrics and materials?
Yeah, I mean, the materials and the layers themselves are one thing. And like I said, we can't really take the suits apart and treat them how we would, say, an aircraft engine, where we can dismantle it and treat every part individually and then put it back together. The challenges also come from the way the layers are adhered and taped together using a special tape called Kapton tape. And those adhesives, which also break down over time, restrict the layers. So when Anne was talking about, interestingly enough, moving in the suit, they've had to come up with ways to actually allow the layers inside to become more flexible and loose when you're using it and pushing against it and doing activities, which we don't see in the early suits. So, you know, it's like taking a helium balloon that's made of mylar, which is one of the layers. And, you know, when it's flat and you have a birthday balloon and you stretch it, it might move one way, but it's not going to move the other way. The materials aren't made that way. But one of the big ways that we see inside the suits, and you can see some of our research online, is we do X-radiography. We have an X-ray unit in the lab. We can actually see the layers of the different materials. We've done CT scanning like you would do using a machine at the Natural History Museum, where they CT scanned mummies. And we've done that for spacesuits. And then we've taken all of that digital data when we produced our online product last summer on Armstrong's suit. So people online can actually see the outer layers of the suit and then look inside the suit to see what we're talking about.
We have a question from Violet in Mexico for Anne. If your spacesuit is broken, how would you know, and what would you have to do?
Yeah, so thanks, Violet. That's a good question. And I lived in Mexico in high school, so from another hometown of mine. So as I mentioned, it's not so much an outfit that you put on, it's a small spacecraft that you get into. And so much like the spacecraft like the Soyuz, or like the coming out of the SpaceX Dragon, or the Boeing Starliner that we're going to fly, we have a whole set of cautions and warnings. We have a whole set of procedures, how we react to those. And so if you look at an astronaut suit, on the front, there's actually like an electronics box. On this one, it would be like right here. And if I look down at that box, there's actually a screen that has messages. And I can scroll through like a normal status of the suit. I can look at what pressure it's at, what temperature it's at, all the different water temperatures measured at different places in my suit that could be indicative of problems in different areas. All of that data is also getting wirelessly sent to the ground. And so we have ground teams, a couple layers of ground teams on the day of an EVA that are looking at every parameter of the suit. And so ground actually would probably see an impending problem long before I did. For instance, if I felt like my carbon dioxide inside the suit was not scrubbing adequately and I started to feel symptoms of that, I would look down and I'd scroll and I'd see that number. Well, long before that, we haven't got to that point, because long before that, somebody on the ground is monitoring that instrument, that trend, and they're seeing a trend come up. And so that's kind of the best way. You do have cautions and warning tones it'll bing into your ear, and then you look down. And again, one of the things, much like when we train to fly aircraft, that we do in our neutral buoyancy lab underwater, is we train how to react to each of those emergencies.
Evan, who is in South Lake, Texas, would like to know how long does it take to conserve a suit? And then, Lisa, if you can also talk about what we've had to do as far as putting Neil Armstrong's suit in a case to keep it safe.
Sure. It can really depend on the suit. It doesn't really take that much time to do the actual conservation treatment, because, as I've said, a lot of the materials are not accessible to us. And a lot of our experience is that we just want to leave as many things intact as possible, so we preserve history and the suit. So most of the research and the digital photography and the analysis we do, that takes the most time. And then over the past few decades, in partnership with Kathy and other team members at NASA, we have studied and come up with a way to preserve the suits the way we know best, which is to control the environment around them. And just like the suit is a spacecraft, we've built a case that we are donning as the next spacecraft for the suit. It is temperature and humidity controlled. We do know that a lower RH preserves plastic and polymer materials. They don't off-gas as much or leach plasticizers or any of the things that were causing degradation in the past. Ventilation is key. We want to move those gases that are continuing to come out even after 50 years away from the materials within the case. We have a scrubber as well in the display case, which catches our gases and returns clean air to our environment in there. We also have worked really hard to develop an innovative mannequin system for Armstrong's display, which is one of the key successes to preserving him on public display. Where we have ventilation now running through the suit, through the mannequin's frame itself. We have more support going to the materials, catching those places that Anne alluded to where there's pressure points and little bends and details in the suit where Neil Armstrong, who wore it, would have had his own body in the suit and would have been able to support those materials in those places. So we've done a lot of research. We're hoping to use this system for future suits. It's a one-of-the-kind project, and it did take a lot of work, probably 13 years to get it back on display for the public. Not working on it every day, but definitely a long time for us to get it on display for the 50th anniversary last summer.
Can I ask you a question?
Of course.
Lisa, is the mannequin the same size as Neil, or did you size the mannequin for the suit?
So we sized it off his original measurements that we got from ILC through Kathy during her research. We did have to scale it down. The suit materials, as you probably know, shrink and sort of stiffen up over time, and moving the mannequin pieces in and out to build it took some other creative forces, because we don't want to put force on the suit, but we want to support those materials. It's pretty close. We used a CNC router with our exhibits production team to cut the inert foam that we use. We built the skeleton out of an aluminum frame and sized it right up, but it's not quite the size that Neil Armstrong probably was when he wore it.
I've been asked to the people sending me questions to mention that the odd noise you may hear in the background is my cat. He apparently wakes up at 1 o'clock as soon as I start these live chats and sings the sad songs of his people. We have an 11-year-old who is a huge NASA fan and is just loving this discussion. And she would like to know, if you could have an improvement on the suit, what would it be? And Kathy, I want to start with you on this question to talk about the improvements that were made from Apollo or even in the Gemini program on, and then Anne, I'm going to ask what you would like to have in the suit.
Well, personally, I want to hear Anne's answer.
Okay.
That's what's important. I mean, the improvements have been improvements in materials, making them more reliable. Obviously, they have to survive for a longer duration. The Apollo suits really had a shelf life, a working life of only 6 months. The materials, most notably the rubbers, the mix of natural and synthetic latex in the suits. So those were the most important suits. And of course, the suits, the Apollo suits and the ISS EMU are different in mission. Neil Armstrong's suit had to be made so he could walk on another surface. Anne and her colleagues don't have to walk. They use their feet to propel them, but not walking on a surface. But your answer is, I'd be very interested, because NASA is working on a new concept, this new exploration EMU. And what suggestions are you making for the next suit? What is the first thing that you'd like to see improved?
Yeah, it's interesting. This question is a lot like I used to fly helicopters, and anybody that's a pilot, you kind of fall in love with the first aircraft that you get to know really well, and then everything outside of that seems like something you have to get used to. And it's a lot like that with the suit. You know, my first reaction is, hey, it's great, works great, lasts a long time. But really, when we look at the future missions that NASA is going to be accomplishing, you mentioned going back to the surface of another planet. Also, just having suits in space for a sustainably long period of time. I mentioned that these suits were built when I was a toddler. When I was a toddler, the shuttle was flying. These suits were going up to space for 10, 14 days at a time, doing a couple of EVAs and coming back to Earth and getting completely refurbished in a lab. And now the suits live up on space station. They're very large, they're very bulky. We don't have the semi-truck space shuttle going back and forth all the time anymore. And so one of the things I think that needs to be addressed is the ability for crew to do on-orbit maintenance. Some of the maintenance that we do on orbit was not designed to be done on orbit. And so we have a lot of little workarounds, how to use a very small needle nose pliers to catch a small screw that you're unscrewing, because you can't have that go into the suit, into a place you can't find it. You also need to use that screw to put the pieces back. So some of the maintenance is difficult to do on orbit. I think we have to think about that for future designs. If we're going to send them to the surface of the moon, that sustainable presence that we keep talking about at NASA, we want to put boots on the moon, we want to leave them there. We're going to have suits that you can work on in zero or reduced gravity, like on the surface of the moon. I also think that there's a lot of preventive maintenance. These suits are well past their design life. And so there's a lot of preventive maintenance. There's a lot of hours that go into getting a spacesuit ready to go out the hatch on an EVA. So some of those are the design considerations. We need to think about how the suit moves for surface missions. Just for familiarization, they let us stand up in the suit one time here when we were getting our first initial fit. And I'm telling you, it's not a suit that you want to walk around in. It does great for the ISS mission, but those boots were not made for walking. So we're going to have to take a look at that. And then perhaps on a practical level, I mentioned that we're outside for 7 hours at a time. We have looked at a lot of different ways that we can get calories into an astronaut's body during an EVA. The only thing we have out there is water. And so if you think about that sustained period of time and working, if we never want to be the limiting factor. So it's very important that we stay fit. But if there was a way that the materials were not so sensitive that we could actually have a sports drink or a caloric drink or even a solid piece of something that we could eat in there, it would make that last hour of an EVA a lot more comfortable for us.
Sounds like you need a conservator on the ISS.
Lisa, Jack would like to know how many people were involved in the conservation of the Neil Armstrong suit.
Oh, we have lots of people. We have collection staff that we work with. We have our curator, Kathy, and her colleagues. We have a team of conservation specialists that I work with. We also work with industry experts, which is our favorite part of our job, is reaching out to people. Not only people like NASA astronauts, but we consult with the actual astronauts from the Apollo program, plus the people who made the suits. Our research is just not done in a vacuum, and we can't give credit enough to all these people, but we work with seamstresses to consult about our mannequin materials. I mean, I would have to say on probably this type of project, there was upwards of 40 different people that I interacted with and researched with. Not to mention, not to give a plug for our Kickstarter campaign, which was awesome and helped support this project, but people came out of the woodwork providing documentation and historical archival information to us on the suit, reaching out to us from all over the country and the world, sending us photos of the suit. We love to see old photos of our displays and our suits so we can see how they have changed through time, because while we think we have all the answers, they may have had a life before in a different part of the museum that somebody's forgotten about or out on a loan somewhere to another museum. So we have just a lot of people, and I can never take full credit for anything we do because we work in a big team.
And I'd just like to put a shout out to our colleagues at the National Zoo, who were the first
Right.
one to an X-ray, at the Natural History Museum, who loaned us time on their CT scanner, other conservators who specialize in textiles throughout the Smithsonian and outside of the Smithsonian. Just a world of people, historians in Delaware at the Hagley Center who have information on the development of both DuPont, who made materials, and ILC.
Abby is in Arlington, and this is a question for you, Anne. Do you sleep in your spacesuit?
No. No. So the spacesuit that you see us when we go out the door, there's way too much adrenaline running through those veins. And you know, when we go outside, we don't just go out to go for a stroll. We don't just go for the view or to take pictures. That's what we do when we happen to have a free spare minute or two. But those entire spacewalks are very choreographed, and we're going out to fix something very important. So, for instance, one of my spacewalks was to upgrade up the power system on the space station, and so we were removing large batteries and replacing them with more modern technology. And so it's a lot of physical labor. You're definitely keyed in, and you're very busy the whole time. And it's even hard to sleep the night after realizing what you just did.
Well, this is going to be the last question. We've got to wrap up here. What someone would like to know: what are the red and blue valves on the Armstrong suit for?
Kathy, you want to take that?
Blue is in with the good stuff, red is out with the bad stuff. It's a simple way to remember. The oxygen supply, the water supply comes in through the blue. It's just to make sure that you don't have a backup. You don't want to mess those up. It's taken from, I think it is actually green and blue on scuba. Somebody should correct me. But those are the colors that have been uniform throughout history. Same colors that the Russians use now on their suits as well. So just to avoid any mix-up.
Well, I want to thank you all for joining us today. I want to let you know that we have a new episode of STEM in 30 that came out today. It's all about volcanoes and Mount St. Helens. We'll have a live chat on Monday for the 40th anniversary of the eruption of Mount St. Helens. And then we have a book chat of pioneering women. That'll feature Mary Cleave and the artist and writer of the graphic novel Women, Astronauts, Women on the Final Frontier. That's on Wednesday. And then on Thursday, we have another live chat, which we will be discussing the Wright brothers. So we've got a jam-packed week next week. We hope you all can join us. And Kathy, Ann, Lisa, thank you so much for being with us today. We really appreciate it.
It's great fun. Thank you.
See y'all next time.